Hi, I'm Miss Hearn. Let's get started. Algebra of functions. So we're talking about functions that have real number values. Any outputs and inputs are real number values. And so we can add functions together just like we can add real numbers. We can subtract them, multiply them, divide them. And when we add, subtract, multiply, or divide a pair of functions, we get a new function. And the new function is going to have its own domain and range and all that good stuff. What we're asked to do in this first exercise is to find the sum, difference, product, or quotient of two functions and then determine the domain of the function. When we have to determine domains, there's three things that I want you to keep in mind. So when you're thinking about the domain of any function, even if you're not adding and subtracting them, you want to keep in mind, number one, all polynomial functions, their domain is negative infinity to infinity, or you can write that as a bold R, all real numbers. Number two, if it's a rational function, which means it has a denominator, we have to exclude values that make the denominator 0. So what you do is you set the denominator equal to 0, solve for x, and whatever you get, you have to leave that out of your domain. And then the third thing you have to keep in mind is, you can't take a square root or any even root of a negative number. So the values under here in the radicand must be greater than or equal to 0. Those are basically the only three domain scenarios that we have to deal with. So as long as you keep those three things in mind, at least in this class, you'll be good to go. Oh, except for when we later talk about logarithms, but we haven't gotten there yet. So let's go ahead and talk about f plus g of x. F is 5x minus 2, and g is 3x squared. And we are going to find first the sum of those two functions, the difference, the product, and the quotient. And as we do that, we're going to also identify their domains. Starting with what does this notation f plus g of x mean? That just means take your function f of x and add g of x to it. So if our function f of x is 5x minus 2, we want to add to that our function g of x, which was 3x squared. Now this is going to be a polynomial, which we like to write in descending order of the exponents. So we have 3x squared plus 5x minus 2, and we've constructed this new function from our original two functions. And since it is a polynomial function, what is its domain? Remember, that was the first thing we talked about as far as the things to keep in mind about domains. All polynomial functions have a domain of negative infinity to infinity. In other words, there's no x value that will cause a problem. It's not going to cause division by 0. It's not going to cause square root of a negative. So we're allowed to use all real numbers, or in other words, an interval notation. Negative infinity to infinity is the domain. All right, let's try to find f minus g of x. This is going to be your f of x function minus your g of x function. And so that would be 5x minus 2 minus 3x squared. This is, again, a polynomial function, so we're going to write it in descending order of the exponents. Negative 3x squared plus 5x minus 2. And so here's our new function, f minus g of x. So our domain, again, a polynomial function, negative infinity to infinity. Okay, let's try finding the products of f and g. F g of x is how it's denoted, but all that means is take your f of x, whatever it's equal to, and multiply it times g of x. So that's going to be 5x minus 2 times what we were told g of x is, which is 3x squared. Now, it wouldn't be wrong to leave it as 3x squared times 5x minus 2. Oftentimes, having a factored form of a function is actually preferable. But I think in my math lab, they're going to want you to multiply that out. So if we distribute this, we would have 15x cubed minus 6x squared. So again, still a polynomial function, so domain is still negative infinity to infinity. All right, so let's find f over g of x, which is just telling you to divide f of x by g of x. This is the first time we're going to have a function that's not a polynomial function because it has a quotient. It's going to be a rational function. So we're going to divide 5x minus 2 by 3x squared. There's no reducing I can do here because there's no factors in common between the numerator and denominator. So that's it. That's f over g of x. So remember that the second thing I mentioned was when you have a rational function, that rational just means fraction, that you exclude the values that make the denominator equal 0. So you set the denominator equal to 0 and solve for x to find the domain. So 3x squared equals 0. Divide both sides by 3. X squared would be 0. That means that x would have to be 0. This is what we're going to leave out of our domain. So I want to give the answer in interval notation. So what I recommend is whenever you have to give interval notation and you're leaving out certain finite values, draw a number line and recognize that you want to include everything on the number line except for that point. So what that does is it divides the number line into two big pieces, right? We have the yellow piece and the blue piece. So the yellow piece is going to be the interval from -infinity to 0, not including 0. So I'm putting a round parenthesis there. Union, and then 0 to infinity is the blue piece. Again, with a rounded bracket, a rounded parenthesis, it's not a bracket because we're not including 0. So this would be the domain of f over g. I hope you found this video useful. If you did, please remember to like it.